Yes, Nabil Ahmed, Nabil Khan.
Sir, I didn't get, sir.
You did not get me assignment.
No, sir, I didn't get it, sir. Is it in what website or is it in the WhatsApp, sir?
No, no, all the assignments, this is for everyone and for always. Remember, the assignments are posted on
Hello, sir.
website, okay, or app, whatever you use. Assignments are posted on website or the app.
Hello, sir. Am I audible?
हाँ खान बताइए. Yes, yes, you're audible. No. Nabil Khan, no?
Yeah, sir. I did not do the assignment.
You did not do it. Why? Or you did not get
Sir,
it?
I did not get it. I thought it was on WhatsApp.
No, no, no. It is always in. Please check it now. Those who have not received the assignment, please check it now on your app or the website. Okay? You will see an assignment there. And I think there will be a bit of time left. So I suggest that please do the assignment.
Sir, for me, it's showing empty page, sir.
Yes, Nabil Ahmed, can you share the screenshot or photo? What are you saying?
Yes, sir.
You have the number now? Okay, wait a second. How many of you are seeing this error message? Your subscription has expired.
I have seen it before, but then if you message Learnivio, they'll renew it after some hours.
Okay, some hours. Okay. Nawal is also getting the same thing. Okay, fine. Nawal. Okay. Saif, Assalamualaikum, how are you? Saif, am I audible? No. Okay. Fine, 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 fine. Okay. So, as we discussed in the last lecture, that we are going to do. What are we going to do now?
Sir,
We
you
are
had
going to
given one question, sir, last class. Can you just show that question again?
Nabil Ahmed, can you repeat what you said?
You had given one question, sir. Which of the following is able to synthesize chlorobenzene? You just show it again.
I could not understand what you were saying. I gave you guys a
Sir.
question, right? You're saying.
Yeah, sir.
Acha, 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 fine, 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 fine. Okay, yeah, this one. What is the answer? How many of you tried? Send the answers. Send the answers. Don't say the answers. Send the answers. Which of the following is suitable to synthesize the chlorobenzene? 1, 2, 3, or 4. Okay. Did you guys try it? या फिर अभी भी आप लोग वही जवाब दे रहे हैं? देखिए. Now, send me the reaction from your notebook. Okay, send me the reaction. We have done this reaction, na? Now tell me, show the reaction, how it is going to happen. Okay, Khalid and Nawal, you have my number, right? The reactant, and then what are the reagents you are using, and then the product also. Okay. So you should also remember that there should be some similar reaction. Now, if you remember, just think of this. Have you ever prepared Have you ever used phenol in the preparation? Once you're answering this, you should ask, have you ever used phenol in the preparation? Staff has sent me something. Yes. Correct, staff. Staff आपका सही है. And I'm waiting for Khalid and Nawal now. What about others? Nabil. Yes, Nabil, correct. Correct. If you go through the notes, then you will know. Nabil Khan. Send me, show the reaction. Show the reaction how you're doing it. Whatever option you're choosing, show the reaction. And also remember, there should be some proof you should have, okay? Like, obviously, we all are not chemists now, at least. There is no Samad in my class. Why is the Samad? Okay. So waiting for Khalid, Nawal, and Nabil. They have said option 1. I'm asking them for a reaction. And also this.
Sir, you got mine, right?
Yours is correct. I was saying Nabil Ahmed,
Okay,
yours is
sir.
correct. I'm asking
Thank you, sir.
proofs. Khalid, Nawal, and Nabil Khan. Once you write a reaction, there should be a similar reaction in your notebook. Okay. There should be a similar reaction in your notebook where we are using the same substrate. That means the organic part, organic reaction, and also the reagent. And so just look. Okay, Hania is here. Let me Hania at least. Jaldi भेजिए. Khalid, Nawal, and Nabil Khan. You all are doing it, right? Yes or no?
Sir, the reaction means that diagram, right? Phenol, arrow, then
Okay.
Cl.
Exactly
Like that.
same. That's it.
Okay.
Now you should also have a proof. You understand what I'm saying about the proof? Nabil Khan.
Yes, sir. Yes.
है ना? So you should say, sir, हमने ये टॉपिक पढ़ा था, उसमें same reaction हो रहा है. Nawal has sent me. Thank you, Nawal. So Nawal, the option that you chose and the answer that you are sending it is completely different. You want to change your answer?
Yes, sir.
Yes, Nawal. Now it is correct. So you will get answers only once you flip your pages. Okay. The more you revise, see, you're getting all the answers from your notebook itself, right? That means the notebook should be in your brain. Okay. Those who are attempting it, they will understand. Nawal, did you get this answer from notebook or somewhere else?
From notebook.
Notebook only, right? This is not only for me, like this is the case with every teacher. If someone is teaching, everything will be from the notes. Okay. Now, what option are you going to choose, Samaira? Everything is correct here.
So
What
the
you have
first
shown
one.
No. But first one, it is phenol. No? Phenol structure is different. What is the structure of phenol? We have OH, right? है ना? Samaira.
Yes, sir.
Now look again. Nabil Khan has sent me something. Where have we used this type of reaction? Tell me, Nabil Khan, which topic? Samad, am I audible? Yes, Samad, am I audible? Hello. आपको कौन सी क्लास करनी है? You are here for which class, Samad? You see, those who want the answer. Now, we have method of preparation. You can see from alkane, alkene, alcohols, not phenols, and electrophilic aromatic substitution, right? So this is one of the reactions in which we are going to use electrophilic aromatic substitution, because this is the only method from which we can prepare benzene rings with halogen atom. Okay, now you must have done the same reaction somewhere here. I think the next page. See? Can all of you see this reaction? Yes or no?
Yes, sir.
Same reaction, right?
Yes, sir.
Okay, Khalid has sent me something. Khalid, but you see that none of the option match whatever reaction you have sent, right, Khalid?
Yes, sir.
I know. Also, for those who were choosing the Sandmeyer's reaction, everything is fine with the first reaction except the thing phenol. If phenol was not there and you had aniline, that means NH2 was here, then this option would also be correct and this option would also be correct. Okay. Fine. Chaliye. So this is one thing that we discussed, and then let us move on to today's topic. This is a new number for it. Okay. Fine. Let us write now chemical properties of halogen. Write the topic chemical properties of haloalkane. Sorry, haloalkane का हो गया. My bad. Haloarenes. Now let us see what is the difference between haloalkane and haloarene and how the reactivity is going to differ. Now, if you look at the structure of haloalkenes, it will be having Rx. Okay, it will be having Rx. Now we know that in Rx, this X will be having delta negative and this R will be having delta positive. Okay, it will be having delta negative and R will be having delta positive. Same thing is here. If we have haloarenes and we have here X, now the polarity in this bond will be what? This CH2 is sp2 hybridized and this is also more electronegative. So both of these halogen atom and sp2 hybridized carbon atom, both of them are what? Both of them are electronegative atoms. And that is why, since the electronegativity difference is not very high here, what is going to happen? They will not show reaction similar to that of haloalkane. Now, since haloalkane is having delta positive charge, it is easily reacting with nucleophile. Nucleophile comes in here and attacks, and it does not have anything which is going to stop it. But if a nucleophile comes and it wants to attack on this benzene ring, then what is going to happen? The benzene ring, it has a pi electron cloud above and below the plane. Okay, so if you have benzene, so this is the benzene ring. Okay, now imagine it as a plane, and there is above, in the above you have a pi electron cloud, in the below also you have a pi electron cloud that is revolving, because all of these pi electrons are in p bonds, and p orbitals are like this. So there is above and below we have some electron density. That is why nucleophile will come and it will be repelled by the pi electron clouds. Nucleophile is also electron rich. It will have more electron. Benzene is also electron rich. So electronic repulsions will be there, and it cannot show the characteristic reaction as that of haloalkanes. Okay. So there comes a question in which they will be asking you guys. Let me keep this here. So this cannot happen, but nucleophile can easily attack on R. This can happen. Now, there's a question that haloalkanes, they show SN. They show SN. You will ask haloalkanes show SN. That means nucleophilic substitution reaction, but haloarenes show electrophilic substitution. Okay. Please remember how to answer this, and you will write the answer exactly how I'm writing, because you will see that सारे questions the same जैसे. You will see some more reasoning questions here in this same topic, and you will be feeling like all of these questions are same. But please remember what the question is asking. He wants you to answer why haloalkane show SN and why haloarene show SE, that is electrophilic substitution. Okay. SE. Right? Now you will write. You have already seen the reason why haloalkane. So in haloalkane, what we have in haloalkane, the alkyl group in haloalkane, the alkyl group, it is attached to what? It is attached to halogen atom. And if it is attached to halogen atom, what is happening? Alkyl group is attached to halogen atom. To halogen atom, due to which partial positive charge is created at the carbon of CX bond. Okay. Now, since we have a partial positive charge, it shows SN. Hence, electron rich nucleophile attacks the carbon of CX, and haloalkenes show SN. Okay. Show SN. Okay. Right, next. But in haloarenes, what is happening? The benzene ring but in haloarenes, the benzene ring has high electron density. Has high electron density. Hence the electron poor electrophiles can attack and haloarenes show SE. Please ध्यान में रखिए. They are not asking why haloarenes do not show SN. You will again get a question. They will ask you why haloarenes do not show SN. There you will give the reason why they don't show. Now what you have to give the reason why they show SE. Okay. Now they have to give the reason why they are showing electrophilic substitution. Okay. So even though these reasoning type of questions are very easy, but sometimes the students they get confused like what answer do I have to write? Please remember whatever is given in the question, just remember that you have to write accordingly. यहाँ पे आपसे क्या पूछा है? But haloarenes show electrophilic substitution. So you will say why it is showing electrophilic substitution. That's it. And when it is going to ask you why it is not showing SN, then you will say this is the reason why it is not showing SN. So you write this fast, and then let's also draw a small representation that a nucleophile, and we have Rx delta negative. Delta positive, it is easily attacked by this nucleophile. But when we have a benzene ring and we have electrophile, now remember, if you are drawing this arrow, this is wrong. Okay? ऐसा नहीं होता कि छोटी चीज बड़ी चीज को अटैक करती है. It's not like that. The arrow is always electron rich to electron poor. So what is electron rich here? Benzene ring is electron rich to electron poor. Nucleophile is electron rich, and the carbon attached to CX is poor. So electron rich to electron poor. Write this down fast. Let me know when you're done. Done, guys. Yes or no, please tell me.
1 minute, sir.
Okay.
Done, sir.
What about others? Done?
Done, sir.
Okay. Right, next. Is there anyone who is still writing? No? Okay. Now all of you write. Topic. Electrophilic substitution of haloarenes. Electrophilic substitution of haloarenes. Now, in electrophilic substitution of haloarenes, we are going to learn the similar, the main reactions of electrophilic substitution that you may have, that you should have heard in 11th standard. You may not be knowing right now. What are those reactions and what are the reagents used? Halogens, halogenation, nitration, sulfonation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. Okay, so please write with me. Haloarenes show the following SE electrophilic substitution. Number 1. Halogenation. Number 2. Nitration. Number 3. Sulfonation. Number 4. Friedel-Crafts. Alkylation. 5th one. Friedel-Crafts acylation. Write a point. Haloarenes on SE gives ortho and para products. Ortho and para products. Okay. Now, why does it give? Haloarenes on SE gives ortho and para products due to resonance. And also write this as mesomeric effect. Mesomeric effect is the product of resonance. It is due to resonance. Okay, mesomeric effect. Now, what do I mean by them? Let us see a haloarene, not alkane. Let's see here. Okay, it can be any other X also here. We know that they have plenty of lone pairs. 3 lone pairs are there in each halogen atom. Okay. Now, one of the condition of resonance is fulfilled. A double bond B, single bond C, and C has lone pair. That is why what you will see a movement of electron cloud like this. So it will go from this lone pair to this pi bond, and this pi bond will go to this carbon atom, and then here you will look at the resonating structure in which it will look something like this. Okay, so now in Cl, this lone pair electron has come to this bond. That means it has made one more bond pi. And here we have Cl. But since Cl has given some electrons to the bond, it will get a positive charge. Okay, it will get a positive charge. This pi electron has moved to this carbon atom, and it will get a negative charge. And the other things are as it is intact. Okay. Now, as you can see, the first resonating structure is also net neutral. Second resonating structure has an atom with positive charge, an atom with negative charge, hence net it is neutral. Further on, again, one more condition of resonance is satisfied. A double bond B, sorry, let me write this with blue, maintaining the consistency here. A double bond B, C has a negative charge. Again, high electron density to low electron density, and pi bond will break into a negative charge like this, and you will get a resonating structure something like this. in which first of all we'll make all the atoms which are not participating. So all the carbon atoms which are in blue, they are participating, the others will be same. So we'll write Cl positive, sorry, Cl positive here like this, as it is. Here we will have a double bond as it is. Now what will happen to this negative charge? It has gone to this bond, so it will become pi. This pi electron has moved to this carbon atom to become negative. Again, there is a double bond B, single bond C with a negative charge. Electron clouds will move like this. This negative charge here, this pi bond and this electron. The pi bond will be as electron in that carbon atom, and you will get a resonating structure something like this. So you have this Cl positive as it is, this bond as it is. This has gone to this negative charge here. This electron has gone to this positive pi bond here. And there is last case in which we have A double bond B, single bond C with a negative charge here. So again, there's a condition for resonance that has to be fulfilled, and will be making the last resonating structure in which this electron will move like this way. Here, and this pi bond will break, and it will go to this chlorine atom, neutralizing it. So we'll have Cl, only Cl, without any charges. The double bond will also break between them. Only Cl. Here we'll have double bond, and then here these things are intact as it is. Okay. I hope you have got a bit of refresher of resonating structures from 11th standard. You must have seen this thing. Now you may recognize it at least, right? And also one more thing, none of these things are real. Each and every structure that we are making right now, it is completely hypothetical. So what is real? In net as a whole, the structure is like this. This skeleton is true. You have 6 carbon atom and 1 chlorine. Till here it is true. But if I label the carbon atoms like this, 1, 2, 3, 4, 5, 6, and 7. So I have numbered all the atoms, not only carbon atom, but chlorine also. Now, if I look at the first bond between 1 and 2, so in the first resonating structure in the A, this is B, let us say, this is C, this is D, and this is E. Okay. So in the A structure, it is having single bond. In the B structure, it is having double bond, C double bond, D double bond, and E is having single bond. That means it is neither completely double nor completely single. And that is why we represent it like this. Okay, it has partial double bond. You will never see it shown like this, but it is always assumed, it is always known. As you know, we have hydrogens right here. So it is always known that the CX bond is always having a partial double bond character. Further on, the 2 and 7 bond is also sometimes double, sometimes single. Similarly, 6 and 7 and all of these are sometimes single, sometimes double. That is why we have a partial double bond. All of the bonds are what? Partial double bonds. Now, if I look at the first Cl atom, it is neutral sometimes. In the B structure, it is positive, C structure positive, it is D structure positive, and again in E, it is neutral. That means it is neither completely positive nor completely neutral. Hence, it has a partial positive charge. It has what? It has a partial positive charge. Similarly, if I go to the seventh one, sorry, not the seventh, second one is always, you can see, neutral, 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 and neutral. It is not having any charge. But if I look at the 7th one, it is neutral, negative, neutral, neutral, and neutral. That means 7th one is also having delta negative charges there. 6th one is what? You can see it is always neutral. 6th one is here, see neutral, 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 and neutral. 6th one will have no charge. The 5th one will have delta negative. As you can see, it is sometimes negative and sometimes neutral. Delta negative. 7th, okay, this one is always neutral, and this one is having sometimes delta negative and sometimes it is neutral. Now, what I can show you from here, if I have an electrophile, an electron poor species, then in this case, it is going to attack from either the ortho position or the para position. So both of these, delta negative and delta negative, these are both ortho position. So either the electrophile attach in the right sided delta negative or the left sided delta negative, that doesn't matter. It does only matter that it is in the ortho position. So I hope everything is clear. Why haloarenes it gives ortho para products? Yes or no? Please tell me, guys. बहुत लंबा लेक्चर किया हमने, समझ में आ गया सबको? नहीं आया?
Sir, how does chlorine get partial positive charge, sir?
Why is carbon getting delta negative charge? Tell me.
That
Because in the net structure, what you can see, there are some chlorine atoms with these are neutral, and some chlorine atom with positive charge. Yes or no? In the resonating structures, है कि नहीं? या फिर आप यही पूछ रहे हैं कि यहाँ पे पॉजिटिव कैसे आया?
yes, sir.
Are you asking this? Huh? Yes, Nabil?
Yes, sir, understood.
Understood, no? So it is giving electrons, that is why it is positive. It is giving a positive charge. And ये जो structure होता है इसको resonance hybrid structure बोलते हैं. This is the real structure. This is known as resonance hybrid structure. Okay, so Saf, you got it? Yes or no? Please tell me.
Yes, sir.
Yes. Okay, fine. What about those students? कौन नहीं थे? Hania, what about you? You're not present with us in 11th standard, I think. Hania?
Yes, sir.
Yes. Okay. Nawal, what about you?
Yes, sir.
Okay. And who else? Both of the Nabil. I guess both of the Nabil said yes, sir, already. Right, Nabil and Nabil. Okay, only one Nabil is here. The other, no,
Yes, sir.
both.
Yes, sir.
Yes, ना? Okay, fine. बाकी जो 11th हमसे पढ़े उनको समझ में नहीं आया तो वो तो फिर थोड़ा सा पानी ले ले, फिर क्या करना आपको पता ही है, right? Khalid, Samaira, remember these things? Yes or no?
Yes, sir.
ठीक है. Done, everyone? Yes or no? There is one meme. You must be very much. You have seen that meme? Jal le lijiye. Have you seen? No one has seen. बहुत थक गए होंगे आप. जल ले लीजिए. Organic chemistry पढ़ते. There's a movie I think which is known as Swades of Shah Rukh Khan, and that there is a very iconic scene. Chaliye. So everyone is done. Now we know that it is going to produce what? It is going to produce ortho and para products. Now we can easily write the answers for the questions. Okay, we can easily write the answer for the question. Number one. Oh no, not pink. Number one. Halogenation. So in halogenation, we will have a benzene ring, and there will be a X atom attached, that is chlorine atom or fluorine atom. Most of the reaction is with chlorine, right? Chlorine here, plus the halogenating reagents are any halogen, let's say Cl2, in the presence of FeCl3 anhydrous, or any of the lowest acid. Lowest acid means it should be having, see, FeCl3, देखिए आप, Fe3Cl. So 6 electrons will be there because we have 3 bonds. Now, if it is having 6 electrons, it is electron deficient, right? It is electron deficient. Okay. Any lowest acid which you are having, we should use that. What is going to happen here? FeCl3. So it's only one of the Cl, it will get attached like this. Cl and Cl plus Cl and Cl. Okay. So this is ortho O dichloro benzene, and this is P dichloro benzene. Okay, this is chlorobenzene. Fine. Now in this, the para product is major, and this product is minor. The reason is when the electrophile Cl positive, it comes and attacks, it sees that there is some hindrance in the ortho position. See, this chlorine will be here now. So this chlorine will be having some electron density around it because it has lone pairs, and that is why the Cl positive will not attack here. Rather, it will attack on the para position, which is completely free. There is no steric hindrance there. Okay. Next point is, how do we know now Cl is getting attached now? So how do we know that this is the electrophile? This is the electrophile. So write a mechanism in which I will be showing you mechanism. Now, in mechanism, you will write the number 1 step. Cl 2, it reacts with FeCl3. You can also have AlCl3 by the way, okay? AlCl3 भी होता है, FeCl3 भी आप यूज कर सकते हैं. Let me give you the example mechanism for AlCl3. The same thing will happen, ठीक है? तो दो reagent आपका cover हो जाएगा एक बार. So you have aluminium like this, and we have 3 chlorine atoms. ठीक है? Now this, what is this here? This is the vacant orbital. So this orbital is vacant, and chlorine atoms, it has lone pair electrons. So one of the chlorine with its bond, it attacks here, and you get AlCl4 negative plus. And since this bond is broken and this bond has gone to Al, electron has gone to Al, you will get Cl positive. Now in step 2, what is going to happen? We have our good old benzene ring, chlorine atom, and I will show this is delta negative. This is delta negative, and there will be Cl positive. Oh, please remember there will be plenty of Cl positive, million of Cl positives, and million of chlorobenzene. This delta negative will attack here, and there can be some attacks from the para position also, and you will get the two products. Cl. Now please remember once the attack happens ना, this here यहाँ पे एक हाइड्रोजन होता है, so वो भी हम आपको लिखाई देते हैं आप लोग. प्रोडक्ट बस याद कर लीजिए, मैकेनिज्म अभी देखिए. Slowly you will understand the mechanism here. Okay, so here we have hydrogen, here we have chlorine. ठीक है, here we have hydrogen, here we have chlorine, and let me make the bonds also. Here it gets a positive charge. Okay, here it gets a positive charge, and we have this bonds as it is. Okay, these bonds are as it is. Okay, and then what is going to happen? AlCl4 will come negative. It will attack on this hydrogen atom. This hydrogen will give its electron here, and then you will get Cl, Cl, pi bond here, and pi bond here. Now, if the para attack is happening, then also you can see chlorine is here. In the para position, you will have the hydrogen atom, which was already present, and then chlorine is attacked, which is already present, and then we will get a positive charge here. We have a pi bond here, and we have a pi bond here. Okay. Now, further on, what is going to happen? Once we get a positive charge here, this hydrogen will be abstracted by AlCl4 negative, and as soon as the hydrogen is abstracted, this hydrogen will lose its electron, and you will be getting chlorine here and one chlorine here. Okay, so write this down.
Thanks, sir.
जी लिखिए आप लोगों ने. Yes, is everyone done?
Yes, sir.
Okay.
Yes, sir.
चलिए. Right, next nitration.
Sir, can you give some examples for Lewis acids?
ये दो एग्जांपल आपको दिख गया. FeCl3, AlCl3, FeBr3. So all of these are examples for Lewis acids. Okay.
Okay, sir.
Sir, anything
Now,
which is electron rich is
electron
electron deficient.
poor, yeah. Acids देखिए. सबसे बेसिक एग्जांपल 10th क्लास में क्या पढ़ा था आपने एसिड का, भाई ये बताइए. What was the most basic thing that was acid? Tell me.
Sir,
What?
can you repeat, sir?
Acid. Achha, I'm saying what was the most basic thing that you learned about acid?
Proton donor.
What? 10th class में पढ़ा था आपने?
Acids are proton donors. They are electron poor. They dissociate into H plus ions.
हाँ तो Lewis acid electron poor होगा, है ना?
Yes,
So the
sir.
most basic thing that you can learn about acid is H plus, and base के बारे में हम क्या याद रख सकते हैं? OH negative.
OH
Right?
minus.
I hope everyone remembers this, H plus and OH negative. Right? Now, if you see H plus, what do you see? Electron poor, right? Because it is positively charged. Base is negatively charged, OH negative. So it will be what? Electron rich. Right? So anything which is electron poor, it can act as Lewis acid, and if it is electron rich, it can act as Lewis base. Okay. Right, next, nitration. Now, in nitration we have the benzene ring, chlorine atom. We treat this with concentrated HNO3 in the presence of concentrated H2SO4. Okay, and in nitration, NO2 is attached, chlorine in the ortho position, plus NO2 is attached with chlorine in the para position. Again, this is major, this is minor. Okay, so here also in the mechanism, I will just show you the formation of electrophile. Okay, so the electrophile is what? Whatever has been attached now. You have what we have attached here, NO2. So the electrophile is NO2 positive. Okay, electrophile will be NO2 positive, which attaches on benzene and get neutralized NO2. So right, formation of NO2 positive, and in which the positive charge is on nitrogen. So nitrogen attaches to benzene ring and not the oxygen atom or something else. Okay. So first of all, the structure of HNO3 is, please listen, don't write. Nitrogen, a pi bond with oxygen and a single bond with oxygen. Again, this is coordinate bond. That means both the electrons belongs to nitrogen, but it is sharing with oxygen. Okay. So that means both the electrons. That means eraser है, eraser आप share कर रहे हैं और आपका दोस्त भी share कर रहा है. Okay, both of you are sharing one eraser. That is what? That is coordinate bond. But for example, if you have brought the eraser and your friend has brought scale and you're sharing both the things, right? So it is mutual sharing is happening here. So that is covalent bond. Now, covalent coordinate bond is that one person is coming up with the electrons and it is sharing with other atom here. So that type of bond is here with nitrogen, and that is why it shows 4 bonds now. And the next bond is with O, and which is further bonded with hydrogen. Now from H2SO4, I hope you understand that from here I will get an H plus ion, and I will get what? HSO4 negative, right? H plus and HSO4 negative. Now from here, H plus ion, it is there. Plenty of H plus ion will be there because H2SO4, which is a very strong acid, it is there. And this oxygen is present with lone pair. It will attack on this hydrogen atom, further making double bond O single bond O, which is dative bond. Dative and coordinate, they are same thing. Oxygen, hydrogen, hydrogen, and then a positive charge. Now, oxygen can accept everything other than a positive charge. Oxygen will say, I am electronegative, I need electron, why are you giving me positive charge? Okay. So whenever you see a positive charge on oxygen, the oxygen cannot have a positive charge for 1 second, 1 millisecond, 1 nanosecond also. As soon as it gets positive charge, it will take all of the electron and leave. And what it will leave as? It will leave as water molecule, which is very stable. It will leave as water molecule, which is very stable, minus H2O. Now, once H2O has left and nitrogen has lost its electron, I will get nitrogen, which is bonded with oxygen like this, and one more oxygen like this with a positive charge. Now, this is the formation of NO2 positive. This NO2 positive is attacked by the benzene. It does not attack the benzene. The benzene ring attacks the NO2 positive because electron rich to electrons poor. And we get the two products, chloronitrobenzene and chloronitrobenzene, ortho and para substituted. Is this clear? Yes or no? Nitration for everyone? Is nitration clear for everyone? Yes or no? Please tell me.
Yes,
Yes,
sir.
sir.
So that coordinate bond part can you say again, sir?
Coordinate bond.
Yes, sir. That what is coordinate bond?
So see here. One electron is brought by A and the other electron is bound by B. Okay. So this is covalent. That means sharing of electron is happening. But this is suppose आपके पास कुछ ऐसा है in which A is coming with 2 electrons and B is coming with no electrons and a vacant orbital like this. Okay, so it has vacant orbital. Now what is going to happen? A will be like, okay, fine, I will be sharing these 2 electrons with you and we will make a covalent bond. Now in this covalent bond, the special thing is both the electrons, they belong to A. You understand this part now? Coordinate bond. Yes, Nabil? Okay. एक आयनिक होता है, आयनिक में क्या होता है? आयनिक में क्या करते हैं? B takes all the electron. So we'll get A positive and B negative. If we have this case in which B is taking all the electrons, then it is going to be ionic. But if it is getting shared, then it is going to be coordinate. Done everyone? Yes or no? Please tell me. हो गया ना सबका? Nitration is done.
Yes, sir.
Yes, sir.
Light sulfonation. Third, no? Now in sulfonation, we use concentrated H2SO4. And we get the product. And ortho substituted SO3H plus we get a product which is para substituted SO3H. Please remember this bond is with sulfur. Here also we'll see. Again, this is major. This is minor. Again, we are going to see the formation of what is getting attached? SO3H. So S will contain the positive charge, O3H. Okay, how it is getting formed. So right here, what happens? The structure of H2SO4 is something like this. There is sulfur doubly bonded with oxygen, and then we have OH. So again, oxygen atom is having lone pair from other H2SO4s. So there will be some H2SO4 which has been dissociated completely, and you will get H plus ion. And this oxygen will attack here, and you will be getting again once you have got the positive charge on oxygen, it will leave forming water, and you will get S double bond O, OH bond here, and double bond O with a positive charge here. Okay, this is how the SO3H is formed. Right, the fourth one. Friedel-Crafts alkylation. Here we will write the introduction of alkyl group on benzene ring in the presence of suitable alkylating reagent is called Friedel-Crafts alkylation. Okay, so let me write the reaction for benzene first, and then we'll write the reaction for haloarene. So we have here benzene plus alkylating reagent. Again, in the presence of, we will use some Lewis acid. Let us use AlCl3 here. Now, this alkylating reagent can be the most important one is RX. We'll use haloalkane, and this is something that we'll be using in this chapter. But sometimes you can also see ROH. If you have benzene type of ring or benzene derivative, you have alcohol and you have AlCl3. Okay, what you're having, you have AlCl3 or ZnCl2, these type of things, Lewis acid, then what is going to happen? You'll again be doing alkylation here. Okay, and if you also have ROR, that is ethers. So in all of these cases, what is going to happen? This bond cleaves, this bond cleaves, and this bond cleaves, and all of them, they give R positive as the electrophile. And in the benzene ring, this R group attaches. ठीक है, साथ में एग्जांपल भी लिख लीजिए. Benzene ring plus I use CH3Br. The presence of AlCl3 भी आप यूज कर सकते हैं. ठीक है. And what are we going to get? We are going to get benzene ring. Now CH3 will be attached on one of the carbon atoms, any one of the carbon atoms. Okay, so this is simple. This is what? This is simple Friedel-Crafts alkylation. Now, what will happen if I have Friedel-Crafts alkylation for haloarene? I will have Friedel-Crafts alkylation for haloarene. We'll have haloarene plus, let us say, CH3Br, presence of FeBr3. So all of these are anhydrous generally, okay, not containing water. Because if water is present, the water का जो H2O है ना, it has lone pair electrons and it can also attack on the electrophile. That is why we don't use water here. So if you have a CH3Br, then what are you going to get? मतलब आपको ये chlorine मिल जाएगा as it is. And in the ortho position, you will get CH3 plus the para position area will also get CS3. Chlorine as it is. Again, this is going to be major, this is going to be minor. Okay. Let's write one more reaction. See, if you have, it's a simple case, okay? If you have something like this, what is this? This is isopropyl bromide, or if you have isopropyl chloride, any of such thing if you have, then please remember in the ortho and para position, the alkyl group will attach via the carbon containing halogen. That means this whole alkyl group will attach, but the bond will be between this atom containing bromine. Okay, so obviously the bromine bond will break and you will get okay. So you make here this bond is with this green carbon atom, and this green carbon atom has two different groups. So you write one group and this the other. ये तो bond आपका बना. This is the new bond that has been formed. Okay, this is the new bond that has been formed. And both the CS3, it was already present with the carbon containing Br. Plus, you will get a similar thing. The para position also. बस Br की जगह आपके पास ये ग्रुप आ चुका है ना? So you have here this bond which is new. Okay, this carbon is the carbon which was having Br and two CS3 groups on that carbon atom. Now let us see why it is happening like this. The mechanism of this particular case. In the mechanism you will see, we have this isopropyl bromide. It reacts with, let us say you have FeBr3. Now here this bromine atom, it has lone pair electrons, and this Fe is having vacant orbital. So this attack will happen like this. First of all, and what are you going to get? You are going to get carbocation. Okay, you are going to get carbocation. Plus FeBr3 will be present. Okay, but you must remember, then what we'll do the reaction with? Benzene with Cl. You have your negative charge, and here you have delta negative charge and delta negative charge. Okay, so this will attack here. Sorry, my bad. This is going to attack. The benzene ring is going to attack from here or from here. Okay, so you will get the ortho product. The first reaction, this will give you ortho product. This will give you para product. Okay. Now, once you have made a carbocation, please remember that the rearrangement can also take place. Okay, for carbocation. I hope you remember the rearrangements. So rearrangement can happen whenever you form carbocation. Done, everyone? Yes or no? Please tell me.
So that
1 minute, sir.
it was a Friedel-Crafts alkylation, but not so sure.
Can you please repeat what you said?
So Friedel-Crafts alkylation definition.
You have to write the definition. आपने लिखा नहीं था जब हम लिख रहे थे तो. लिखे. Now, please remember, if you write this reaction now, the suitable alkylating reagent may you will write Rx. Okay, the presence of haloalkane and Lewis acid. Lewis acid आप लिख सकते हैं. You will understand. And also, whenever they ask you to write a short note on a particular name reaction, write the sentence or the definition or the short note, correct? Write the statement for that reaction, but please never forget to make the reaction. Draw the diagram also. Draw the structures also. Show the reaction. If you don't have time, don't write the statement. Rather, draw the structures and draw the diagram. Okay. Show the reaction. Also label everything whenever you're doing an examination. So you write under benzene, benzene, and you write in the product alkyl benzene, ethyl benzene, whatever it is. Okay. Then also if you have major and minor, please show major and minor. But these are what? These are just these are the dressings of your food that you have prepared. Okay. The main, the main meat of the product or the main thing that you have to write is the reaction, and you have to show it with structures. Done everyone? Is please tell me.
Yes, sir.
Done. Is there anyone who is still writing?
Just 1 minute, sir.
आपने कुछ नहीं लिखा क्या नबील अहमद?
Sir, this last 2 ones are in right.
Okay.
Done, sir.
Done. Very good. The last one is craft acylation. Right. The introduction of acyl group. The introduction of acyl group in benzene ring the presence of suitable in the presence of suitable acylating reagent. Okay, acylating reagent के आप ब्रैकेट में लीजिएगा acyl halide and Lewis acid. Okay, acylating reagent is called Craft acylation. So you have benzene ring plus a suitable acylating reagent. So the acylating reagents are plenty. And here we are using Lewis acid. The one which we are using, acyl halide, it is having structure R, C double bond O, X. Okay, this is what? This is acyl halide. Then you can also have R, C double bond O, O, C double bond O, R. This is known as anhydride. Other acylating reagent can be R, C double bond O, H. What is this? This is aldehyde. Other reagent can be R, C double bond O, OR, which is ester. And all you can see is that the breaking of bond will be this X will leave with its electron like this. This bond can break like this. Okay. and then here this will break, and here this will break. Okay. And what is going to form? You will have the benzene ring. Now, the positive charge will be on carbon atom. So write carbon. Carbon has a R group. You write the R group. Carbon has a double bond. You write the double bond. Let us see how the reaction will happen with haloarene. Haloarene. That's what we are going to use. We are going to use R, C double bond O, Cl. In the presence of AlCl3. What are we going to get? Ortho and para substituted. Okay, wait a second. ये R मतलब कि यहाँ पे CH3 कीजिए please. My bad. Specific reaction here. So here what will happen? This chlorine atom will be liberated. Why it will be liberated? Because you know that this chlorine atom will attack on this AlCl3 directly, right? Now this will generate a positive charge on this carbon atom. So हमने ये क्या बनाया? यहाँ पे ऐसे carbon atom बनाया. So this carbon atom has a double bond. So double bond दिया. It carbon atom has CH3. So you have given CH3 plus. What else it is going to make? Ortho substituted हो गया, para substituted. In para substituted also, I have made this bond with carbon atom because carbon is having positive charge. Then it is having what? Double bond also. So I will give it double bond like this. And I will give it CH3 group like this. Write this down. Done everyone? Yes or no? Please tell me. Yes, done. Okay.
1 minute, sir.
1 minute.
Yes, sir.
Sir, the second compound is the major one, right?
Yeah, correct. Done now?
Yes, sir.
Yes, sir.
Yes? Okay, fine. Okay. Now listen very carefully. Now comes the important part. When I look at SE of Haloarene, we are looking at electrophilic substitution reactions of haloarenes. Okay. Now, there are two things important in electrophilic substitution of haloarene. First thing is that we have seen already, that is the orientation. Okay, what does it tell me? Orientation, it asks you about on what positions will the electrophile get attached. Okay, this is orientation. Other thing is that we have to remember about haloarene is the reaction or the reactivity. Reactivity. So what is reactivity? What question does it ask? It asks me about how fast does the reaction occurs compared to benzene. Okay, compared to benzene, right? Now, orientation, it is controlled by resonance. Okay, and therefore ortho and para products we are getting. So the orientation is what we are getting, ortho and para products. But if I talk about the reactivity, then in haloarenes and compare this to benzene, then the benzene is showing faster reaction than haloarenes. Now they will ask you a question. Even though we see that the resonance is happening and you see that the electrons are getting pumped into the benzene ring, and if the benzene ring is electron rich, then the electrophile should be easily attacked by the benzene ring. Okay, so they will ask you, even though like this, even though haloarenes, they give ortho and para product, but still they are deactivating. They're what? They are not activating, they are deactivating. So they will ask you, although chlorine is an electron withdrawing group, yet it is ortho para directing in electrophilic substitution reactions. Why? Okay, so both of these questions can be asked. They can ask you, even though chlorine is what it is, electron withdrawing group. So you will write this: halogens are electron withdrawing groups. Okay, electron withdrawing groups. Okay, but via minus I. Okay, this is very important. Now, since in haloarenes, this is what very electronegative, so it takes up all the electron. So even though the electron density increases in ortho and para position due to resonance, the reactivity is controlled by what? The reactivity is controlled by inductive effect. Okay, so there is a very important line written in NCERT. It is written that reactivity is thus controlled by the stronger inductive effect, and orientation is controlled by the resonance effect. Okay, so we'll write here. What is the reason here? I will explain each and everything, but in some of the lines you have to remember as it is. Okay, so we'll write here what you will write in haloarenes. Yeah, in haloarenes, the reactivity is controlled by the stronger inductive effect Okay, stronger inductive effect and orientation is controlled by resonance effect. Okay, controlled by resonance. Second. Write this down. Okay, Nabil, fine. Okay, is everyone done?
No,
Sir,
sir.
what is that line, sir? Halogens are electron withdrawing.
Via minus I. Via. VIA via minus I.
Sir, and what was those questions, sir? You said.
नहीं हम सब लिखाएंगे वही लिखाएंगे. Don't worry.
And sir, what is minus I?
Inductive effect is again. For example, when carbon is bonded with magnesium, so carbon is more electronegative. Magnesium is giving electrons to carbon, right? So when carbon receives the electron, it is plus I through the difference in electronegativity. But when carbon is present, and if you have halogen, halogen is having more electronegativity. So halogen will get the electron, and it will attract electron. So that means halogen is showing what? Halogen is taking electron, so halogen is showing minus I. Got it now?
Yes, sir.
Okay, so it is the shifting of sigma electrons. Inductive effect of yaad kar lijiye, it is shifting of sigma electrons due to difference in electronegativity. Okay, this is inductive effect. Minus inductive, minus I मतलब कार्बन से इलेक्ट्रॉन्स जा रहा है, प्लस I मतलब कार्बन के पास इलेक्ट्रॉन आ रहे हैं. Is everyone done now? Are still writing?
Then, sir.
I think.
And
No,
sir.
no, sorry. Done now? Okay. All right. एक सवाल आपसे पूछा जा सकता है. Haloarenes are less reactive towards benzene. Oh, sorry. Less reactive towards Se than benzene. Se than benzene. Why? No, reasoning में आपसे पूछा था. You will answer it. Due to more powerful minus I effect of halogen atom electron density at benzene ring decreases. At benzene ring decreases. Which decreases the stability of carbocation formed and slows the attack on electrophile. Slows the attack on electrophile. No reason, hence it is less reactive to Se than benzene. Please remember, देखिए आपके पास see this positive charge being formed. Carbocation बनता है, कहाँ पे बनता है? Benzene ring में बनता है, right? So in all of the cases, you will find this positive charge carbocation. Okay. In the second step, I have not shown the second step in everywhere. I've shown the first step, but second step is similar. You can just replace this Cl negative with any other electrophile, and you will always get a carbocation. Now, since we have minus I effect, chlorine is extracting electron, pulling electron. What happens? The carbocation gets unstable, and that is why the attack gets slower, and hence it is less reactive to Se than benzene. In benzene, we don't have any minus I group. Okay, so this is one question that they can ask, and you will answer it like this. Okay. Right, another question. Haloarenes are strong electron withdrawing groups. EWG is strong with electron withdrawing groups, but still they give ortho and para products. Ortho and para products. Okay, the answer you will know. First point. Haloarenes are electron withdrawing groups due to minus I. Okay. But since they show resonance, the electron density is higher at ortho and para position. जब ये हम बोल रहे हैं ना, which is higher at ortho and para, when I say higher, तो higher किससे higher? Higher, it is a comparative thing. So it is higher at ortho and para than the meta position. Okay. So if you will have look at the meta position, then it will not have electron density which is high, but it will be higher at ortho and para position than higher than meta होगा. Okay. तो कंफ्यूज मत होइएगा, कहीं हम बोल रहे हैं इलेक्ट्रॉन विड्रॉइंग भी है और फिर बोल रहे हैं कि इलेक्ट्रॉन डेंसिटी हायर भी है. दिस इज इलेक्ट्रॉन डेंसिटी, इलेक्ट्रॉन डेंसिटी is higher at ortho and para position. Okay. The next point. Therefore, they give ortho and para products as the orientation is controlled by resonance and the reactivity is controlled by conductive effect. Done everyone? Jasola, please tell me.
1 minute.
Yes.
चलिए last point वाले सब लिखिए. Write the topic. Okay, nucleophilic substitution reaction of haloarene. Right, the first point, as we have seen earlier, haloarenes, they don't show nucleophilic substitution reaction at room temperature. Okay, so right here, haloarenes don't show SN at room temperature. Okay, due to following reasons. Due to following reasons. देखिए अब ये सवाल है ना जिसमें आप कंफ्यूज दे विल आस्क यू. एक सवाल क्या था आपका? दे कैन आस्क यू व्हाट एज वी हैव सीन अर्लियर. ये स्टेटमेंट पढ़िए आप. Haloarenes show SN but haloarenes show electrophilic substitution Y. ठीक है, ये सवाल एक हो सकता है. Similar to this question is what? Haloarenes don't show SN. ठीक है, तो यहाँ पे आपको रीजन क्या देना है? यहाँ पे आप ये नहीं बोलिएगा कि वो इलेक्ट्रोफिलिक सब्स्टिट्यूशन दिखाते हैं, उसके बारे में पूछ ही नहीं रहा है. You will tell the reasons why it does not show. सारी बातें SN के रिलेटेड होनी चाहिए. न्यूक्लियोफाइल and you will say about the carbocation. Okay, न्यूक्लियोफाइल कार्बोकेटाइन. न्यूक्लियोफाइल कैसे अटैक कर रहा है, क्यों नहीं अटैक कर रहा है, वो सारी चीजें बताएंगे. ठीक है, so write the first thing. Following reasons. Number 1, partial double bond at CX due to resonance. Okay, and then what you will do, you will make the resonating substitute. Fluorine, Cl positive, so electron will go here, negative, double bond, and then further resonating substitutes are there. One reason. The next reason is instability of phenyl carbocation or phenyl cation. Phenyl cation. Okay. Now, if it is going to show a resonance, sorry, if it is going to show nucleophilic substitution reaction, then what should happen? This X bond should break, and you should get a phenyl cation like this. So this phenyl cation is surrounded by sp2, more electronegative atoms. This is why it is very unstable. There's nothing to stabilize this. Okay? There's nothing to stabilize this. अगर phenyl cation stable नहीं है तो SN1 नहीं हो सकता. Let us look at another reason. Third reason. Due to repulsion between electron-rich nucleophile and electron-rich benzene ring. Okay, ये तो self-explanatory है. Electron-rich benzene ring is also electron-rich. Nucleophile is also electron-rich. That means nucleophile can never attack on the benzene ring. अब nucleophile attack ही नहीं कर रहा तो SN2 भी नहीं हो सकता है, right? If this can't happen, this is the first step of. This is the first step of what? This is the first step of SN1. SN के दो ही cases हैं हमारे पास. There are only two routes, SN1 or SN2. It cannot show SN1 because instability of cation, and it cannot show SN2 because electron-rich nucleophile is repelled by electron-rich benzene ring. Right, the fourth one. the sp2 carbon of CX bond does not have enough partial positive charge attract the nucleophile. Yes. These are the 4 points.
Sir, reason for which Haloarene doesn't undergo SN2 is because of third one, sir.
Third one, and then similarly fourth one also, है ना? Because fourth one में क्या है, nucleophile attack नहीं कर पा रहा. Why? Because it carbon sp2 carbon, it is not having enough partial positive charge. Okay.
And SN1,
Main reason
SN1
is, sorry,
for SN1, what is the reason, sir? Why Haloarene doesn't go? 1 and 2.
SN1 is second reason, है ना? Instability of phenyl cation.
Okay, sir.
SN1 में we make formation of carbon is the first step and is the rate determining step. If that cannot happen, the reaction will not proceed. But SN हो सकता है 2 condition पे. Okay, is right. Haloarenes can show SN under 2 conditions. Number 1, इसको बोलते हैं drastic condition. Drastic condition. Drastic condition में क्या होता है? इसमें होता है high temperature. That means at high temperature and high pressure. Second आपके पास है by placing electron withdrawing group at ortho or para position. Okay, so look at these 2 cases where haloarenes can show SN. चलिए लिखे सबने SN में?
No, sir.
No, जल्दी लिखिए.
Yes, sir. Done.
Done. Everyone done? Yes or no? Please tell me.
Done, sir.
ठीक है.
Yes, sir.
See, this is very important. Please अच्छे से पढ़ के जाइएगा इस टॉपिक को. Okay.